In Algebra 2, Section 2.8, we're dealing with graphing linear and absolute value inequalities. So graphing inequalities is different because we're going to be doing shading, because you have more than just a line of answers or a V of answers for inequalities. There's multiple things that can make things true. For example, if I'm doing x is greater than 2, I have all the answers that are greater than 2 as that could be possibly for my x, as opposed to x equals 2 can only be 2. So if I have my equation, I'm going to first focus on the equation itself. So I'm going to rewrite this so that it has an equal sign. Okay? And then I'll bring in the inequality later. So this is something we've already seen. I need to graph this. All right, and I can graph it. There's different methods you can graph it. I'm going to put it into y equals mx plus b form. You can use a table, you can use intercepts, but I'm going to use the slope-intercept form and then graph it that way. So in order for me to do that, I need to move everything to this side. So I'm going to subtract x. So I get 2y equals negative x plus 4, because I need the x first. I'm going to divide both sides by negative 2. This is the whole thing by negative 2. This cancels out. I get y equals negative x over negative 2, because I have to give this to x and give it to 4. I have to give it to both parts that any term that's split between x and y, and then plus 4 over negative 2. I end up with y equals x, positive 1/2 over it. 1/2 x plus, minus 2. Okay, so here's my equation that I'm going to graph. So first I'm going to graph it like it's a regular line. I'm going to start at negative 2, because this is my y-intercept, and I'm going to move up 1 and over 2. So up 1 over 2, up 1, up 1 over 2, up 1 over 2. Right? So I do it like 2 or 3 times, up 1 over 2. Okay. If my graph was made better, it would look more like a line, but sorry that it doesn't. But here's the thing. When we're graphing, and this doesn't have a line on here, then that means the information on this line is less than, but it's not included. So what I'm going to do is, if there's no line underneath, I'm going to, instead of putting a solid line, I'm going to put a dotted line through this. Okay, if there was a line underneath, this would be a solid line. Because there's no line underneath, I'm going to put a dotted line. Yes? So this line then splits the graph into 2. It splits into this part and this part. And the question is, okay, there's only one part I can shade. And how I find out, so the first thing is I'm going to draw the line. Oh, it's right here. This is 1. I graph the boundary. And then 2, I'm going to test the point. So basically, I'm going to pick a point that's not on the line. Okay, it can't be on the line. Not on line. Okay? So I'm going to choose an easy point, which is 0, 0. Okay, I'm going to test this point. This is my x and y. And I'm going to plug it in to my original equation. Okay? So I'm going to plug this in to my original equation. So I'm going to put 0 for x minus 2 times 0 is less than 4. This is where the inequality comes back in, because I'm going to check it. Well, 0 minus 0 is less than 4. 0 is less than 4. This is, in fact, true. Here's the thing. This is the point that I tested. Okay? This point says true, so that means anything on that same side is true. If this was false, if I ended up with 0 is greater than 4, and this was a false statement, then I would shade the other side of the line, because this is not true, so everything else on this side should be true. See how that works? So since this is true, the side where the point's on is the side that I shade. So then I shade everything on this side. Right? So the first thing is to graph the boundary. Now it could be different, because when we're doing absolute value, your boundary might be a V, it might not be a line. But this, we're going to graph the boundary, and the second one is to test a point that's not on your boundary, not on your line. All right? And then you test. If it's true, you shade in that point that has it. If it's false, you shade in the other side. So go ahead and pause it, write this down. We're going to do one with absolute value and see maybe if you're getting it a little bit more. All right. So number 2 is asking for y is greater than the absolute value of -2. So because this is an absolute value, I'm going to go ahead and create a chart. Because my first step is to graph the boundary. So x, the value of x minus 2 equals y. Remember, again, I'm going to treat this like y equals, yes? Now, if it's not y equal, if y is not on its own, I have to solve that first, like I did for the first one. But because it's already, y is already isolated, I don't need to do anything, and I'm going to create the chart. So let's do -2, -1, 0, 1, and 2. So the absolute value of -2 minus 2 is 2 minus 2 gives us 0. The absolute value of -1 minus 2 is 1 minus 2 gives us -1. The absolute value of 0 minus 2 is 0 minus 2, which is -2. The absolute value of 1 minus 2 is 1 minus 2, which is -1. And the absolute value of 2 minus 2 is 2 minus 2, which gives us 0. So we have -2, 0. Sorry about that. We have -1, -1. We have 0, -2. We have 1, -1, and we have 2, 0. So here's our v. But because there's a line here, I do a solid one. I'm not going to do dash. Again, if that line wasn't there, this would be a dash line. But because that line is there, we're doing a solid line. So now it still splits the graph into half, right? Into 2 parts. Either this part on the outside of the absolute value or this part on the inside of the absolute value. So I have to decide, my next step is to decide which part do I shade. Well, I'm going to test the point. Test any point that's not on my line. Well, this is not on my line, 0, 0, so I'm going to test, I like that point. So I'll keep using 0, 0, but doesn't mean you have to use 0, 0. Like if the line was on there, I would do 0, 1. But I would stick somewhere close by with easy numbers. So we have 0, 0. And I'm going to plug it into my original equation. Y, value of x minus 2. So this is my x, this is my y. 0 is greater than or equal to 0 minus 2. Yes? So then I end up with 0 is greater than or equal to -2. Is this true? Is 0 bigger than -2? This is in fact true. So because this is true, everything that's on the side of here would be shaded in. I wish it wasn't true because the other one was true, but it's fine. If it's false, again, I would be shading the outside instead of the inside. All right? So go ahead. This is my first step is to, again, graph the boundary. My second step is to test a point that's not on the boundary. Write this down and try page 119, number 3 and 7. 119, number 3 and 7, and I will see you in class.